Great white sharks. Is there any sea beast so feared by humans?
In 2003, off the coast of southwestern Australia, scientists clip a tracking tag to a healthy great white shark and watch her slip into open water. 4 months later, the tag washes up on a beach. The shark never does, and the data sealed inside it describes something nobody believed was possible: a 500-pound apex predator, the animal that nothing in the ocean is supposed to hunt, dragged nearly 2,000 feet into the dark and swallowed whole. Something ate her. Something we had never measured, never filmed, never named, and it would take scientists years to admit what had truly been hiding down there. The shark that vanished.
What we do is enable scientists to create and collect data by giving them safe access so you can use things like a spot tag.
The year is 2003. A research team is working off the coast of southwestern Australia, running the first large-scale great white tagging project those waters have ever seen, and Riggs is on board to film it. The work is slow and patient, the kind of thing that does not make for dramatic footage. Hours of waiting broken by a few minutes of controlled chaos when a shark finally comes alongside. And then one does, a healthy female, around 9 feet long and roughly 500 pounds. There is something about the way she moves, a kind of ownership, a confidence that is not aggression, but something closer to certainty, as if the water belongs to her, and she is simply allowing everyone else to share it. Someone on the crew starts calling her Alpha. The name sticks. Hold on to those numbers, because they matter more than they look. 9 feet, 500 pounds. This is not a juvenile. This is not an animal still figuring out the edges of its range, still learning what it can and cannot push around. This is a fully grown apex predator, the kind of creature that has sat at the summit of the ocean's food chain for millions of years and has never once, not in its entire life, had a reason to look over its shoulder. Nothing in her world hunts her. That is the entire point of being what she is. The thing they attach to her is a data logger, small, rugged, unremarkable to look at, built to do exactly one job for months at a time without ever broadcasting a signal. It records depth. It records the temperature of the water around the shark.
It showed this profile going down the shelf to 580 meters and then a huge temperature change.
It captures light levels and movement, second by second, and it holds all of it inside, silent, patient, saying nothing to anyone. It is not a tracker beaming her location to a lab in real time. It is a witness that keeps its notes to itself. Then, on a preset date, it releases, floats to the surface, and finally transmits everything it gathered up to a satellite, so the scientists can reconstruct where she went and what she felt down there, provided she is still wearing it when that day comes. And here is the part you have to sit with, because it changes everything that follows. That little device is the only witness. No camera follows Alpha into open water. No diver, no boat, no second pair of eyes. Whatever happens to her out there happens in total silence and total privacy, in a part of the world where no human is watching and no human ever will. The only record that will ever exist of the last chapter of her life is the one written quietly inside that tag. 4 months pass, and then the tag comes back, but not the way it is supposed to. Not by satellite, on schedule, from open water. It comes back physically, washing ashore on a beach roughly 2.5 miles from where it was first attached. Someone finds it, the data is recovered. The numbers go up on a screen, and everyone in that room is braced for the ordinary, for the boring, for exactly what you would expect. Slow cruising patterns, temperature drifting gently downward with depth, the wide, lazy loops of a big shark moving through familiar water. That is not what the tag says. That is not what the tag says at all. The only witness.
Within seconds, the shark tag recorded a dramatic temperature shift from 46 to 78 degrees Fahrenheit.
It shows a drop, not a dive, not a gradual slope into deeper water. A plunge, nearly 1,900 feet straight down, and it happens in minutes. And then, right as the depth bottoms out, the temperature reading does something that stops the whole room cold. 2 numbers. That is genuinely all it takes. 2 readings sitting next to each other on a screen, and the moment Riggs understands what they mean together, this stops being a research project and quietly becomes a question that will follow him for years. The kind of question you do not get to put down once you have picked it up. But before I hand you those two numbers, you have to feel what kind of animal we are actually talking about. Because I think most people carry a vague sense that great whites are dangerous without ever really sitting with what that word means. And if you do not understand what alpha was, you will not understand why what happened to her should have been impossible. A perfect predator. A great white is not just a big fish with good teeth. It is millions of years of relentless evolutionary pressure refined into something that operates right at the outer edge of what biology will even allow. The largest individuals push past 20 feet and weigh more than 5,000 pounds. They can detect a single drop of blood diluted into an enormous volume of water. They can feel the faint electrical flicker of a heartbeat buried under sand, sense it through organs clustered in the snout that have no equivalent in your body at all. And in a short burst, they can close distance on prey faster than that. Prey can even register the threat coming. Their teeth are serrated and endlessly replaced, stacked in rows so that the instant one breaks, the next simply rotates forward to take its place. A weapon that repairs itself across a life that can run half a century or more. The oldest, largest great whites are not just big. They are decades of accumulated size and instinct. Animals that were already hunting these waters long before any research vessel ever arrived to study them. But the teeth are not really the point. The point is position. An apex predator is, by definition, an animal that nothing hunts. Everything beneath it organizes its entire existence around avoiding it. And above it, there is supposed to be nothing at all. That is what apex means. The ceiling, the end of the chain. And for as long as anyone had studied great whites, that was the rule, full stop. Orcas had been seen harassing them, even killing them in a handful of documented places. Big sharks had been seen scuffling over carcasses. But something that deliberately hunted a fully grown great white, killed it clean, and ate it as a meal, that was not in the model. That was not supposed to be possible, which is precisely why nobody standing in that room wanted to be the first to say out loud what Alpha's tag was clearly telling them. The first number. The first number is depth, nearly 1,900 feet, and on its own, before you bring in anything else, before the second number even enters the picture, that reading is already wrong. Great whites are not deep water animals. They are built for the bright, productive, sunlit layers near the surface, the coastal shallows, the upper zone where light still reaches and prey is thick and life is dense. The overwhelming majority of a great white's entire existence happens within the first 1,000 feet of water. That is their world, top to bottom. So a sudden vertical plunge to 1,900 feet is not foraging. It is not a curious animal wandering a little deeper than usual. When a tag logs that kind of rapid, extreme descent in a matter of minutes, the list of things that could possibly explain it gets very short, very fast. Alpha was almost certainly not diving on her own. Something was taking her down. Something that could reach 1,900 feet quickly, powerfully, and apparently without much effort at all. And I want you to really picture where that is. Down at 1,900 feet, the sunlight is gone completely. The pressure is crushing, dozens of times what you would feel standing at the surface. It is cold, it is black, it is silent in a way that nothing on land is ever silent. This is not somewhere a coastal hunter casually wanders. Something dragged Alpha into a place that was never hers, did it in minutes, and left behind no sound, no struggle anyone could see, no trace, and no witness but the tag. Think about what that descent alone would demand. To pull a 500-pound apex predator that deep, that fast, you need something powerful enough to overwhelm a great white, fast enough to do it before she could fight back. And at home, in a part of the ocean, great whites almost never enter. Whatever did this failed none of those tests. Quick thing before I give you that second number. If you are the kind of person who finds all of this more fascinating than frightening, who leans in instead of looking away, you are exactly who this channel is built for. Subscribe to Reef Discovery and stay with me, because this is the precise point in the story, where the strange tips over into the genuinely impossible, and I do not want you to miss where it goes. The second number, temperature. At 1,900 feet off the coast of Australia, the ocean is cold, not cool, not chilly, genuinely deeply frigid, sitting at around 46 degrees Fahrenheit. And here's the thing, if the tag had simply popped off Alpha and sunk down to that depth on its own, or if Alpha had died and drifted down into the dark with it still attached, then 46 degrees is exactly precisely what you would expect that sensor to read. Cold, and getting colder the deeper it went. That is the normal story. That is the boring story. That is not the story it logged. The temperature went up. It climbed from around 46 degrees to a sustained 78 degrees Fahrenheit. That is a jump of more than 30 degrees in the wrong direction, at a depth where the water should have been getting colder, not warmer. And it did not spike for a second and fall back the way a damaged, dying sensor might. It held steady, 78 degrees, 1,900 feet down, in water that should have been close to freezing, holding that warmth like it was the most natural thing in the world. And there is really only one explanation for that. A tag does not log a warm, stable 78 degrees at that depth, in that ocean, unless it is no longer in the ocean at all. It was inside something. Something with a warm interior, something alive that had swallowed Alpha whole, tag and all, and then carried her down into the dark with the meal still inside it. Sit with that the way Riggs had to sit with it. Something out there in that water swallowed a 500-pound great white shark whole, dove nearly 1,900 feet, and then simply carried on with its day. And not one single person at the surface saw a thing. No fin breaking the water, no disturbance, no photograph, no splash, no sound at all. The only reason any of us know this ever happened is that a piece of plastic washed up on a beach 4 months later, carrying the receipt. He read it, and reread it, and reread it again, and he could not make those numbers say anything other than what they so plainly said. The shark was eaten, and the question started right there. The suspects. So the team did the only thing they could do. They started working through every animal the ocean could possibly offer, every candidate big enough and capable enough to do this. And one by one, they watched each theory die. First, the orca. And the orca is a serious candidate, because we know for a fact that orcas kill great whites. Off South Africa especially, they have developed a technique that is almost surgical in its precision, flipping a shark upside down so that it locks into a paralyzed trance-like state, then opening up the body cavity to extract the rich, nutrient-dense liver and leaving much of the rest behind. It is cold, efficient, and genuinely impressive. So at first the orca seemed to fit. A gut full of warm prey, plus a swallow of cold seawater, could plausibly produce a reading somewhere near that 78 degrees. The temperature did not rule the orca out, but the depth did. Orcas are not deep divers. They hunt near the surface, and even their most extreme recorded dives fall well short of 1,900 feet. An orca does not casually drag prey down to that depth and linger there. The behavior simply did not match the body. So they turned to the sperm whale, an animal that genuinely lives in the deep, that chases squid down thousands of feet into the dark, far deeper than Alpha ever went. The largest males stretch past 60 feet and weigh over 100,000 pounds, and a throat like that could take a 9-foot shark without any difficulty at all. On depth, the sperm whale was no problem whatsoever, but the temperature cut against it from the opposite direction. Sperm whales are warm-blooded mammals, running internal temperatures of around 97 to 99 degrees. 78 is far too cool to be the inside of one, and their entire feeding strategy is built around soft-bodied squid in the deep, not large, muscular surface predators. Wrong temperature, wrong diet, out. And do you see the shape this is taking? Because this is the whole case in miniature. Every single suspect big enough to reach that depth ran too warm, and every suspect in the right temperature range simply could not reach that depth. The data had quietly drawn a box around the predator, an invisible set of requirements, and almost nothing in the entire ocean fit inside it. And that is the part that should make the hair on your arms stand up. It was not that they could not find the predator, it was that the predator they were hunting for had to be something the textbooks quietly insisted did not exist. Every safe, familiar, comfortable answer had been picked up and set back down. Whatever was left was going to be strange by definition, and they all knew it before anyone said it. They looked at other large sharks, a giant tiger shark maybe, or an oceanic white-tip. Both aggressive, both highly opportunistic, the kind of animal that will try to swallow nearly anything that fits in its jaws. But neither species grows large enough to take a 9-foot great white whole. The biggest tiger sharks on record cap out around 14 feet. And to consume a 9-foot shark entirely, you do not need to be a little bigger than your prey. You need to be enormously, decisively bigger. The math simply would not close. There was even a brief stretch where someone floated the idea of a colossal squid, something theoretically large enough to wrap around a shark and pull it down into the dark. But that theory did not survive contact with the temperature, because a cold-blooded invertebrate has no warm interior at all. Its body is simply the temperature of the water around it. There was no warm cavity to find. One by one, every ordinary answer burned away. Orca, wrong depth. Sperm whale, wrong temperature, wrong diet. Large sharks, not large enough. Squid, cold-blooded. And as that list finally exhausted itself, the team found themselves staring at a possibility that was somehow both completely obvious and almost too strange to say out loud. The predator revealed. What if the animal that ate the great white was another great white? Not a slightly bigger rival that won a fight, not a territorial collision that happened to turn fatal. A great white of a size that most marine biologists had never seriously put on the table. A shark so large that a 9-foot, 500-pound great white was, to it, nothing more than a meal. And they did not guess their way to that conclusion. They reasoned it, and once again, the temperature was the key that unlocked it. There is something almost unbearable about where that reasoning leads, because it means the answer was never some unknown monster lurking at the edge of the map. It was the same animal, the thing we already thought we understood, inside and out. The most studied, most filmed, most famous predator in the entire ocean, quietly hiding a version of itself we had simply never managed to measure. Most sharks are cold-blooded. Their internal temperature matches the water around them, and that is the end of the story. But great whites are not most sharks. They belong to the mackerel shark family, and they carry a rare and remarkable adaptation called regional endothermy. Using a specialized network of blood vessels, they trap and recycle the heat generated by their own swimming muscles, keeping their core, their eyes, their brain, and crucially their digestive system meaningfully warmer than the cold water surrounding them. It is the very thing that lets them stay fast and lethal in cool water where other predators slow down. Now, follow that logic all the way down, because this is where it lands. An average great white's stomach might run somewhere around 65 to 70 degrees, and in deep, frigid water, even that figure is probably generous. 78 degrees is warmer than a normal, mid-sized great white would ever produce. But a significantly larger great white changes the entire equation. More body means more muscle. More muscle means more heat generated. And more sheer mass means that heat is held far more effectively against the cold pressing in from every side. Inside the gut of a truly enormous great white, a stable 78 degrees is not a contradiction at all. It is exactly what you would expect to find. The reading that had looked like a glitch suddenly pointed straight at one specific kind of animal. And the depth fit too, once you let go of the old assumption that great whites stay shallow. Because these sharks have actually been tracked diving past 3,000 feet in the open ocean. 1,900 feet is extreme, yes, but it is well within reach of a very large individual. That left just one question. How big does a great white have to be to swallow a 9-foot shark whole? Researchers who study this kind of predation use a rough working rule of about twice the prey's length. Run that against what the tag recorded, and you land on a predator somewhere around 16 feet long, weighing more than 2 tons. A shark sitting right at the upper edge of what the species is believed to reach, and maybe, just maybe, slightly past it. Let yourself reconstruct the moment, and it is brief and merciless. A larger shadow rising up from below. The way great whites attack. Fast, committed, coming up from underneath in a single explosive strike, and then the long, dark fall downward with the meal still inside. The tag did not record the ambush itself. It recorded the aftermath, the plunge and the warmth. A single piece of plastic, reconstructing from temperature and depth, alone a death that no living eye ever witnessed. And the aftermath is more than enough to tell you exactly how it began. What else? Here is where it stops being arithmetic and starts being genuinely unsettling. For more than a century, there have been credible accounts, from fishermen, from naval crews, from researchers, describing great whites of 20 feet or more. And for a long time, science mostly filed those reports away under exaggeration. Stretched memory, the natural inflation of a terrifying encounter retold over years until the shark in the story grew with every telling. But what if they were not exaggerated? What if the ocean genuinely holds great whites of a size we have simply never managed to tag, to measure, or to photograph. Animals that live far out in the deep open water, away from the coastlines and the vessels and the shallow bays where almost every bit of our observation actually happens. The longer you sit with that idea, the more sense it makes that we would have missed them entirely. The largest, oldest females would be the rarest animals in an already rare species, roaming thousands of miles of open ocean and surfacing for no one. A shark like that could live a 50-year life and never once drift within sight of a research boat. We did not fail to find her because she was hiding. We failed because we were never once looking in her part of the ocean. And the team's conclusion pointed to exactly that, a female great white of exceptional size. Because females of the species grow considerably larger than males, and the biggest confirmed individuals approach 20 feet and weigh well over 4,000 pounds. When the researchers laid Alpha's recorder alongside the tracking data from other large white sharks moving through those same waters, it aligned. The body temperatures logged from bigger animals matched the warmth recorded inside the tag. The depths matched, the ranges matched, the behavioral patterns all lined up, every one of them consistent with an enormous female great white that had simply never been formally documented by anyone. And that is a genuinely uncomfortable thought, because it means the gap in our knowledge is not random. It is shaped almost perfectly, like the exact animals most capable of surprising us. The bigger and rarer and deeper an individual lives, the less likely we were ever going to see it, which means the most extraordinary great whites in the ocean are precisely the ones our science was built to miss. She had been there the entire time, moving through those waters, doing exactly what apex predators do. And one ordinary morning in 2003, she crossed paths with a 9-foot great white and treated it like breakfast, then carried it nearly 1,900 feet down into the dark to finish the meal, somewhere no one would ever see. I genuinely do not know how to make that less alarming, so I am not going to try. The moving ceiling. Once the team accepted what had happened to Alpha, they did what good scientists always do when something impossible lands in their lap. They went back through the record, hunting for patterns they had previously waved away. And great whites eating great whites turned out not to be a freak accident at all. It is documented behavior, and the evidence had been sitting in plain sight for years. Larger individuals are known to dominate smaller ones at feeding sites. Juveniles are genuinely at risk from the adults sharing their water. And the behavior even begins before birth, with developing pups consuming their own unhatched siblings inside the womb, a strategy so well established that it has its own name in the scientific literature. Dead great whites have washed ashore carrying massive bite wounds, the arc, the spacing, the serration that could only have come from the jaws of another great white. And it is not only the dead ones. Researchers and divers have photographed living great whites carrying old, healed-over scars in that exact same unmistakable pattern. Sharks that were bitten by one of their own kind and somehow survived to swim away. And more recently, researchers tracking a pregnant porbeagle, a smaller cousin of the great white, recovered data suggesting it had been attacked and very likely consumed by a larger predator, with a great white among the prime suspects. It was described as the first documented predation of a porbeagle anywhere in the world. Take any one of these cases on its own, and you can explain it away. A turf fight, a squabble over a carcass, two big animals simply having a bad day in close quarters. Scientists are trained to resist drawing dramatic conclusions from isolated data points, and they are right to be. But lay the whole body of evidence end to end, stretch it across decades, and then drop Alpha's tag right on top of the pile, and you cannot honestly call all of it aggression anymore. The very largest great whites do not just compete with the smaller ones. Sometimes they eat them, and that matters far, far beyond the fate of one shark. Because we have always used the great white as our anchor, our benchmark for the very top of the ocean, the ceiling above which nothing else exists. But if the great white is itself sometimes prey to a larger member of its own species, then the ceiling is not where we placed it. The apex is not a fixed point. It is dynamic. It depends on size. And we are in no real position to argue otherwise, because the honest truth is that we have barely looked. The Pacific alone covers around 60 million square miles. All the world's oceans together stretch past 100 million square miles of water, and we have meaningfully explored only the thinnest sliver of it. Worse still, the great whites we actually do tend to be the smaller, younger ones that come close to shore, while the giant females live far out in the deep water, where the research boats simply are not. It is like trying to understand wild elephants by only ever studying the calves near the fence. And our conservation models, the ones we use to protect this species, run on that same thin, skewed sample. They account for fishing pressure and the fin trade and habitat loss, but they do not seriously account for great whites being eaten by other great whites, which means the real population picture, and very nearly everything we have built on top of it, may be quietly, fundamentally off. And it runs deeper even than head counts. We already know that the simple presence of great whites reshapes the behavior of everything beneath them. The seals, the sea lions, the smaller fish, entire communities that organize their whole lives around the threat. So, if giant great whites are quietly reshaping their own population from the inside, the ripple effects of that run all the way down the chain, completely unaccounted for, in ways we have not even started to measure. Pull one assumption out from the bottom of an ecosystem, and you do not get a small, tidy correction. You get a quiet cascade, every estimate downstream of it nudged a little further from the truth, and no one entirely sure by how much. And we never even named her, not the predator. Alpha was the one that was eaten, the one we can name. The other, the one that did it, has no designation, no photograph, no record of her own. She did the single most remarkable thing science has ever inferred about her species, and then she vanished back into the same dark ocean she came from, unseen, uncounted, and as far as anyone knows, still out there. If you want a sense of what an animal like that might actually look like, consider Deep Blue. And Deep Blue is real. She is the largest great white ever reliably filmed, a female estimated at around 20 feet long and roughly 4,500 pounds, captured on camera in 2013 off Guadalupe Island, Mexico, and believed to be close to 50 years old. She is staggering to watch. She makes a research cage look like a child's toy, and I want to be completely, absolutely clear about this, because it matters. There is no evidence connecting Deep Blue to what happened to Alpha. Different oceans, different animals. No one has ever linked the two. I bring her up for one reason, and one reason only, to show you that great whites genuinely do reach that size. The thing that took Alpha was not a monster from a story. It was a shark, an ordinary shark of an extraordinary size, doing an ordinary shark thing. And somehow that is worse than any legend, because we so badly want to believe that we have basically solved the ocean. That we have mapped it, named it, sorted it into tidy categories, handed everything a Latin name and a row on a chart, and then looked at that chart and told ourselves we understand what is in the water. We do not. We are still, well into the satellite age, discovering large marine animals for the very first time. Creatures bigger than a person that slip past us for generations. And if that is still happening, then the confident belief that we have already met the largest great white in the sea starts to look a lot less like science and a lot more like wishful thinking. Alpha's tag drifting ashore 4 months after she vanished was a message from the deep, and what it said in effect was that something is down here that you did not account for. Something larger than you believed was possible. Something that treats your apex predators as prey and dives nearly 2,000 feet to digest the meal in private. Somewhere out there, right now, another tag is already attached to another animal, quietly logging the next thing we are not supposed to know. And when it washes ashore, I will be here to tell you what it found. So subscribe to Reef Discovery now, and you will be here when it does. And tell me in the comments, if the real top of the ocean was hiding from us this entire time, then what else do you think is still down there, waiting?